Hello and welcome to another video from Mastery Tutoring. So in this video we're going to be doing a question from analytical geometry. It's a grade 12 question. So now the question reads as follows. It says line AB passes through the point A and has an angle of inclination of 153.4 degrees. Now the coordinates of A are given as 0 and 3. Now, and also angle of inclination, we know that it is an angle that is formed from the positive x-axis, meaning that it is drawn from the x-axis in the first quadrant. Whether it can move clockwise or counterclockwise, but then given the fact that this one is positive, it has to move counterclockwise. Okay, now these are the equations that we have to solve. We need to determine, number one, we need to determine the equation of line CD, which passes through the point C, and also given the coordinates of C, which is 2 and 3, and then also we are given that line CD is parallel to line AB. And then question 2, it says determine the equation of line EF, which passes through the origin and is perpendicular to both AB and CD. So in this case, actually, we're going to have to apply, remember that there's that rule that says if you multiply the product of two lines which are perpendicular, will give you a negative one. So we're going to have to apply that rule in order to solve this question. Question 3 says sketch line AB, CD, and EF on the same system of axes. And then lastly, question 4 says use two different methods to determine the angle of inclination of EF. So now let us go ahead and solve this question. But then before we do that, right, I want us to draw a Cartesian plane, because anyway, question 3 requires us to represent this information in a form of a Cartesian plane. So let us just go ahead and represent the first information that we given there, the given information, because it makes it much easier to sort of like understand, it gives you like vision to see where you are and where you need to be. So now allow me to draw the Cartesian plane that we're going to be using here. So this is going to be the Cartesian plane. This is going to be the y-axis. This is going to be the x-axis. And then now we are given that our coordinates, actually, that we're given the coordinates of A, which is 0 and 3. So obviously when you're given coordinates like this, one should know that the 0 is the x coordinate and the 3 is our y coordinate. So now we're going to go ahead and put this in a form of in the diagram. So this is our coordinate here. So 0 and 3, they meet at this point. Suppose this is the point where this is going to be our coordinate for A, which is going to be 0 and 3. So now we're going to have to draw a line. But then remember, this line has to pass through point A, and then it has to intersect with the x-axis, because of this information here, we are given the angle of inclination. So it sort of like guides us, because the angle of inclination is measured from the positive x-axis. So now, drawing that line, the line will cross at that point. So, but then this line I have to make it has to be longer. Let me make it pass through point A. So it goes to that point there. So now this is point, let's call this point point B. Let's just call it point B, because they didn't tell us where exactly point B is. And then now this angle is going to be 153.4 degrees. So we draw that angle of inclination. So this arrow, actually, it shows that this is an angle of inclination, because it starts from the positive x-axis going to the line AB. All right, so we've represented the first part of the question in terms of in the Cartesian plane. Now question 1 now. So we're doing question 1 now. It says determine the equation of line CD, which passes through the point C. We're given the coordinates of point C, which is 2 and minus 3. We have to represent this on the diagram. So now suppose now this is the point 2 and point 3. Let's say they meet somewhere there. Let's say this is point 2 remember, we don't really have to be like on to do like exact, to be exact on our diagram, on our Cartesian plane, because this is not drawn to scale. So suppose this is point 2 and this is point 3. So these 2 points, they meet here at this point here. So let's call this point C. And then now we write our coordinates, which is 2 and minus 3. And then now we need to draw the line. But then again, the line has to be parallel to, allow me to erase this. The line has to be parallel to, the line has to be parallel to line AB. So now drawing that line that is parallel to AB, maybe it can come from, say it comes this way, like that. So these 2 lines are parallel. I think that looks parallel. So now, remember, we also give, so this is line CD, but then we don't know where D is sitting exactly. So what we can do here is we can just, select a random point along the line CD and just name it D, because we don't know where D is sitting. So allow me to say that's going to be my point D. But then we can calculate the exact position of point D, but then that is something that we can do later after getting the equation of the line CD. Now to get the equation of line CD, we're going to have to apply the rule that says the slope of line AB is equal to the slope of line CD. So what I'm saying is, we know that the slope, or the gradient rather, of AB is equal to the gradient of CD. This is because the lines are parallel lines. Let me just give a reason here. Remember, you don't have to give these reasons, So this is because line AB is parallel to line CD. Now we're gonna go ahead and calculate the slope of AB. So MAB is equal to the tangent of theta. Now you're probably wondering as to what theta is. What is theta? Now theta, I'm going to name theta the angle of inclination. So theta is equal to 153.4 degrees. So now moving to that side now, we say MAB is going to be tan of 153.4 degrees. Now this gives me a slope So my slope now, I'm going to use my calculator here because I'll need a calculator for this one. So it gives me minus 0.5007, which is approximately minus 0.5, I can rewrite this as minus 1 over 2 because 0.5 is the same as 1 over 2. So this is my slope for line AB. Now I need to take this slope now and calculate the slope for line CD. So because now these lines are they have the same slope, so the slope of CD is going to be equal to the slope of AB, which is equal to minus 1 over 2. So given this information now, we can go ahead and determine the equation of line CD. So y minus y1 is equal to m CD x minus x1. So we're going to use the coordinates of C. So the coordinates of C are, so now our x1 and y1, we're going to get them from C. So the coordinates of C is 2 and minus 3 because they're given to us here. Here they are, 2 and minus 3. So we're going to apply that. So now putting that information in the equation, we have y minus, this is going to be minus 3 is equals to minus 1 over 2, and then you have x minus 2. Okay, I'm going to continue on the next page. So now we're going to take all these terms to the other side. So we're going to take this minus 3, but before I take it, actually, let me do this just not to confuse you. So this is going to become y plus 3 is equals to minus 1 over 2. Okay, let me multiply this. Now I'm going to multiply this negative half into the bracket. So this is going to give us minus 1 over 2x and plus 1. Because when you multiply negative 1 over 2 and minus 2, it gives you 1. So we have 1 there. And then now taking the 3 to the other side, this will become y is equals to minus 1 over 2x plus 1 minus 3, which ultimately the equation of CD is equals to, of line CD, I mean to say, is equals to minus 1 over 2x minus 2. It's supposed to be a 2. There is our equation there. So we've solved the first part of the equation, right? So the equation, so now you can even, if you like, you can go ahead and put this equation, put this equation on the, put this equation rather on the graph, on our diagram there. Let us move on to question 2. Now question 2 says that we need to determine this question 2 here. It says that determine the equation of line EF which passes through the origin and is parallel to, sorry, is perpendicular to line A, to both line AB and CD. So now this line has to be it has to be perpendicular to the 2 lines that we have on our diagram here. So allow me to draw that line. So I'm going to draw, so it has to pass through the origin. So we can draw any line that passes through the origin. So suppose here's our line here. It passes through the origin like that. Alright, so this is in such a way that this is 90 degrees there. And then this is also 90 degrees. So this is our equation. So this line is in such a way that it is parallel to, so they're calling it EF, line EF. So suppose this is point E and this is point F. So it's our line EF. So now they want us to determine the equation of this line, right? To find the equation of line EF, this is going to be equation 2, right? We know that the slope of EF times the slope of AB should give us minus 1. Therefore, MEF is going to be minus 1 over MAB. We know from the previous example that MAB is minus 1 over 2. Therefore, we substitute it here. So MEF is going to be minus 1 over minus 1 over 2, which ultimately becomes just 2. Therefore, the slope of EF is equals to 2. We've done our first part of the question. So now, we need to do the second part now. The second part of the question is just to put this information in the diagram. To put this, so the second part of the question is to use this slope together with the general formula of a straight line to find the equation of EF. So we know that y minus y1 is equals to m. So now this is going to be the slope of EF. MEF, x minus x1. Now x1 and y1, they come from the fact that line EF passes through the origin. So the coordinates of the origin, which is O, is 0 and 0. Alright, so going back, let me go back to the diagram just to explain this point. Here's our origin there at this point here. Now the coordinates of our origin is going to be 0 and 0. Hence, I wrote 0 and 0 there. Now we're going to substitute these values here, the 0 and 0, into our equation, our general equation for a straight line. So where there's y1, we're going to put a 0, and also where there's x1, we're also going to put a 0. So this is going to be y minus 0 is equals to our slope. We've calculated it to be 2. So this is going to be 2 into x minus 0. The resulting equation is 2x. Now this is equation for line EF. Okay, so now let us move to question 3. Question 3, it says we need to sketch line AB, CD, and EF on the same system of axes. We've already done that. This is the diagram here that shows all this information. So we have line AB here, we have line CD, which is this line there, and then also we have line EF. But then now what we need to do now is to go ahead and show these equations that we've calculated on our diagram. So let us show these equations, right? So we know that line EF, let me extend it so that I have more space to write. So this is EF. We know that line EF is equals to 2x. We know that. And then also we know that line CD is equals to y is equals to minus 1 over 2 x minus 2. These are our lines. So question number 4, okay, we're done with question number 3, so we're moving to question number 4. Question number 4 says use 2 different methods to determine the angle of inclination of EF. So here's line EF here. We need to find the angle of inclination. The angle of inclination for line EF will come, remember, angle of inclination always drawn from the positive x-axis. So it will go from this like that. Let us call it alpha. So we're going to call our angle of inclination for line EF as alpha. Now we need to solve this question using 2 different methods. All right. So the first method, which is the easiest method, right? This is question 4. The first method will be to, so we know that the slope of line EF is equals to the tangent of, is equals to tan alpha. We know that. We already know the slope, which is 2. We can just substitute here and then calculate the angle there. So this is going to be, this will serve as our method 1. Okay, let me just write here on top to say method 1. This is method 1. Okay, so we know that tan alpha is equals to, slope is 2, so we put 2 there. And then alpha will become, now we have to put this in our calculator. Alpha is going to be, so now I'm punching this in my calculator, and then it gives me 63.4 degrees. 63.4 degrees as my angle of inclination. So that's the angle of inclination for line EF. This was method 1. Let us go to method 2. Method 2. So now for method 2, I want to bring out the following. There's a rule from mathematics. Suppose we have a triangle. Let's say we have a triangle this way. This is my triangle. This is my triangle. Or rather, maybe I should use, let me use what is in the diagram, Let me use the scenario that we have here. Okay. So from this diagram, we can see that 153 degrees is an external angle from the triangle BFO. So it's an external angle there. So according to the rules of when you're doing Euclidean geometry, the rule says that if you have an angle outside a triangle, that angle it is equals to the sum of the opposite 2 angles. So now meaning that 153.4 it is equals to 90 degrees and alpha there. So now we're going to do it that way. So alpha plus 90 degrees gives us 153.4. So we need to give a reason, right? So you can just say exterior angle is equal to sum of interior opposite angles. So you can just give a reason like that. Therefore, alpha is going to be 153.4 degrees minus 90 degrees, which becomes 63.4. So we've solved the question. Now, if you like, you can go ahead, you can go back into your diagram and put this information. But anyway, this brings us to the end of the session. This was a very good question, I hope this somehow, it opened the way you see mathematics and the way you would have solved it. And then for those who have questions, who have more questions, please leave comments. And those who haven't subscribed to the channel, please go ahead and subscribe. This is your tutor Gara, and signing out. Goodbye.